In the winter sky, rising like a mythic warrior, Orion dominates the celestial stage. His belt of 3 stars draws our gaze, but it's his shoulder, glowing with a crimson hue, that holds one of the most mysterious and volatile stars in the night sky, Betelgeuse. Pronounced Betelgeuse, Betelgeuse is no ordinary star. It is a red supergiant, swollen, unstable, and on the brink of destruction. For thousands of years, people have looked at this star without realizing it's a ticking time bomb. Now, with modern astronomy, we know its death is not only inevitable, but imminent on cosmic timescales. And if it were to explode right now, the effects would be dazzling, historic, and far-reaching, both for the night sky and for our understanding of stellar life cycles. What would happen if one of the brightest stars in our sky suddenly died? Betelgeuse is colossal. It is among the largest stars visible to the naked eye, and its scale is difficult to comprehend. It is estimated to be over 900 times the diameter of the Sun. If you could replace the Sun with Betelgeuse, its surface would reach somewhere between the orbits of Mars and Jupiter. But its size is not the only extraordinary thing. Betelgeuse is a Type M1 red supergiant, a late evolutionary stage of massive stars. These stars burn through their fuel at breakneck speed, and Betelgeuse is estimated to be only 8 to 10 million years old, young compared to the Sun's 4.6 billion years, yet already in its final phase. Massive stars like Betelgeuse live fast, die young, and die explosively. As it nears death, the star's interior is layered like an onion. At its core, iron builds up, the element that signals the end. Unlike lighter elements, iron doesn't produce energy through fusion. When enough iron accumulates, the star can no longer support its own weight. Gravity takes over, and the collapse begins. This internal drama is hidden from us. All we see from Earth are changes in brightness and structure. Betelgeuse pulses irregularly. It expands and contracts over hundreds of days. Sometimes it dramatically dims, as it did in 2019. Was it a prelude to death, or just another convulsion of its dying breath? When the collapse begins, it will happen in a flash, literally. The iron core will implode in under a second. Temperatures will surge to billions of degrees, and protons and electrons will fuse into neutrons. The core becomes a neutron star, or perhaps collapses even further into a black hole. Then, with no more support, the outer layers of the star will fall inward, crash into the dense core, and rebound in a tremendous shockwave. This rebounding matter, mixed with intense radiation and neutrinos, will blow the star apart. This is the core collapse supernova, one of the most violent events in the universe. It will briefly release as much energy as the Sun would produce over its entire 10 billion year lifetime. In that moment, the light curve, the graph of brightness over time, will rise steeply. But even before the light arrives, neutrinos will reach us. These ghostly particles, barely interacting with matter, will flood through the Earth. Deep underground detectors will pick up the first signs, the whisper of an explosion 550 years in the past, only now reaching us. Then, hours later, the light will hit. To observers on Earth, the event will begin with a sudden point of brilliant light in Orion's shoulder. It will rise in intensity over days, eventually becoming as bright or brighter than the full moon. For weeks, it will be visible in daylight, a glowing star, persistent even under the sun's glare. At night, it will cast shadows. People all over the world will step outside and see a new, bright star where Betelgeuse once was. It may appear bluish-white instead of red, due to the extreme heat of the explosion. It will remain bright for months, slowly fading as the supernova's remnants expand and cool. We will watch with awe as the star that had watched over us for millennia blinks out, replaced by an expanding nebula, a cloud of gas and dust that will continue glowing for years. The sky, as we know it, will never look the same. Orion will be permanently altered. Despite the incredible power of the explosion, Earth will be safe. Supernovae are only considered dangerous if they occur within 30 light years. Betelgeuse is over 550 light years away. At that distance, the gamma rays, X-rays, and high-energy particles will have diffused and will be too weak to cause biological harm. There will be no mass extinctions, no global radiation events. Satellites and electronics will remain unharmed. Earth's atmosphere will absorb any excess radiation long before it can reach the ground. However, what we will experience is a data flood. Instruments around the world, in space, underground, and at mountaintop observatories, will capture everything. Neutrino detectors, gravitational wave observatories, and high-speed cameras will all record the cosmic event from multiple angles. We'll study the physics of the explosion, the composition of the ejected material, and the formation of new atomic elements in real time. It will be the most studied supernova in human history, a once-in-a-lifetime window into the life and death of a giant. Supernovae are not just destructive, they are creative. The elements that make up our bodies, carbon, oxygen, calcium, iron, all were forged in the hearts of stars. But most were not released into space until a supernova tore the star apart, scattering those ingredients across the galaxy. Betelgeuse's death will enrich the interstellar medium, the space between stars, with heavy elements and dust. That material will mix into new molecular clouds, eventually collapsing into new stars and planets. Some future world, orbiting some future star, might carry atoms that were once part of Betelgeuse. In this way, the death of one star becomes the seed of new life. It's not an ending, it's a transformation. And it reminds us of the deepest cosmic truth. We are made of star stuff, born from the ashes of long-dead stars, just like Betelgeuse. The truth is, it already has. If Betelgeuse were to explode today, the supernova would have actually occurred over 500 years ago. Light travels at a fixed speed, and what we see in the night sky is the past, not the present. So when we look at Betelgeuse tonight, we are looking half a millennium into the past. If it explodes now, the explosion happened during the age of Da Vinci, before the telescope was even invented. It's entirely possible that the supernova has already occurred, and we are simply waiting for its light to reach us. The Great Dimming of 2019 gave us a glimpse of this possibility. For weeks, Betelgeuse dimmed to less than half its normal brightness. The world watched, breath held. Was this it? Scientists ultimately traced the dimming to a massive dust cloud expelled from the star's surface. But even that, the ability of Betelgeuse to shed its outer layers in such dramatic fashion, is a sign of just how unstable the star truly is. The clock is ticking, and when the moment arrives, we will have front-row seats to one of the most profound events in the observable universe. There will come a night, or perhaps a day, when we will look up and see it. A new star, a brilliant flare, the final breath of a dying titan. We will remember where we were when it appeared. We will tell stories. We will teach students who will grow up never having known a sky with Betelgeuse in it. And we will study the aftermath for decades. A great cosmic eye will have blinked closed, leaving in its wake a glowing nebula, the ashes of a giant. But in that death, there is beauty. In that destruction, there is creation. And in that moment, we will once again feel our deep connection to the universe. For we are stardust, children of supernovae, witnesses to the life and death of stars. And Betelgeuse, even in death, will teach us more than most stars do in life.